All right, so here is my development environment. This is Visual Studio Code with Platform IO, and I'm going to walk you through how to find the library you need for this Adafruit feather, and let's control that NeoPixel on board. So first, what we're going to do, we're going to name a new project in the Platform IO area. We're going to name it, and we're going to select our board. Now I'm going to type a little bit here to try to get the specific board that it is, because it filters the drop down and we find the S3 TFT right there. Everything's good, so we finish. And it's going to go ahead and create everything that we need to inside of Visual Studio Code. Now you got to give it a minute here, because although I'm clicking Platform IO or platformio.ini in the main C program, Platform IO will still initiate itself there so that we can do something. We want to go look at the libraries eventually, but those will go in the platform here, and the main CPP has our two setup and loop functions. So here we're going to go into libraries and run a search for Adafruit. Now there is this NeoPixel bus, but in my search I found something else called Adafruit NeoPixel, and we're going to use Adafruit NeoPixel. I know it works, but we're using the Express if32 type library, so and it's from Adafruit, so we know it'll work with the Adapixels. So for installation, this is what we need to put in our platformio.ini. So I'll copy that and go to my open platform.ini. We'll create a lib_deps entry here, and then I will just paste that. That's all I need to do to make sure that it loads that. Now on the headers over here, we know we need to include that header. So I'll go to the main CPP and we'll add an include line to make sure that we've got that in our program. We got that running. Now, how do we even use that library? Well, fortunately, Platform IO gives us some hints in the way of examples. So we need to declare the NeoPixel. And so I'll copy that declare function over, and that goes before setup. Now, we've got some things we need to specify. So the first parameter is the number of pixels, and the second one is the pin number. Now remember, the onboard's only one, but remember how we have some preset? So if I enter pin underscore, I can automatically pick the NeoPixel pin that's built into this board. And that sets up our function on the variable strip. So I think we've got that function ready to go. Got one pixel, and it's going to hit that NeoPixel pin. So we'll come back over here, and there's a couple of things in setup that we're going to need. So I'll just copy those off. Go back to here. Stick that there. And then we'll clean it up just a little bit. So that begins our strip. We're going to set the brightness to 50, and we're going to go ahead and make sure everything's okay. Now there's function in the loop that we want to call. We want it to cycle the rainbow. Remember on the preset program, we have a wheel. So if we just put rainbow in here, but how's it going to know how to call rainbow? And that's where we go back to the examples, because in this example, this particular library, they include the functions that you're going to need to be able to show the rainbow. And notice the rainbow itself, this function that comes up here, because it's a function that we're going to call from our program, includes a function called wheel. Now, scroll down a little bit in the examples, and we get what that wheel function looks like. And it's built in. I mean, this is all documented in the library that from Adafruit that Platform IO uses. So because we got to call wheel inside rainbow, I'm going to put wheel before rainbow. Make sure we've got everything that we need. And I think that we're close. We got the wheel function. It doesn't call anything funky. It's calling things from that strip. We've got the setup. We've got the loop. Now let's check to see if it compiles. So we're going to open up Platform IO on the left. We're going to click on Build. Now what Build is going to do is it's going to download the library, and then it's going to go ahead and compile everything for us. And since this is first run, it's going to go ahead and grab everything from Platform IO's framework that it needs to do. Here's the Arduino items, and then and it's specific to this TFT. It's creating, it got our main.cpp. That's good. So if you get to the firmware.elf and it goes everything, it's going to compile successfully. So now we want to upload this. I have my board already plugged in. I'll show you that in a minute. And so it's going to go through and looking for the upload port, and then put that board into load mode, and then copy the program up. And I'm on a little older machine, so this isn't bad, but it's not speedy. And then once we get to there, now we need to go back to the board. All right. And so here we are on the board. This is off that same camera system I was using. I hit the reset button there, and there is our cute little LED on board running through the cycles, and it's running rather fast. I kind of want to slow that down. Let's go back to Visual Studio. All right, so here we are back in Visual Studio. I'm going to go ahead and close all that. Now, this rainbow function is a wait. It puts a delay in there, so I'm going to increase that to 50. And the only thing that we should need to do is just click upload. It will automatically recompile what we just did. So we're going to let it go through and redo our main.cpp, and then relink it, and then repush it back up to the board. And I'm not going to speed anything up, just because this is kind of what you should expect to see whenever everything runs. And we're finished. Let's go ahead and go reset our board and see what that looks like. Here we are on our board. It's been reprogrammed. We're going to go ahead and press the reset button. And we're getting a color change, and it is at least 2.5 times as slow, right? Because we increased that number from 20 to 50 milliseconds. And there we go. We've now programmed our onboard NeoPixel using 2 libraries and just a little bit of code. Yeah, I hope you enjoyed this. I'm actually on my USB webcam now using a really cool feature of NVIDIA Broadcaster that's now in beta that automatically keeps eye contact, because I'm actually looking at my OBS here on my desktop that you can kind of get a glimpse of whenever after I blink, after I open my eyes, and then the AI inside of NVIDIA Broadcaster is just repointing them and doing that. I just thought that was kind of interesting, and my first time to ever try this out. So thanks for watching, and I think next we're going to try to do stuff with that TFT display.